Assalamualaikum and good day to all my channel. I hope you are in good health and safe in this pandemic. Before I proceed with my presentation, I would like to introduce myself. My name is Muhamad Farid Marudin with Matric number B051820070. So for the Bachelor Degree Project 1, title is Preparation and Characterization of Calcium Phosphate from COCKLE shell to corn method for biomaterials applications. This project is supervised by ADIBAH BINTI Muhamad. So for the presentation outline, it consists of 3 chapters. For the first chapter is an introduction. Next, for the second is a literature review, and the last is a methodology. Introduction part, background study. We have all keywords that are important in this part: calcium phosphate, COCKLE shell, calcium carbonate, and hydroxyapatite. Calcium phosphate have widely been developed in biomedical applications due to their excellent biocompatibility, bioactivity, and osteoconduction characteristics. Calcium phosphate found in the many ceramic forms such as porous block, dense body granular forms, and hybrid composites. To produce calcium phosphate is by extracting it from natural sources such as eggshells, animal bones, and cockle shells. Cockle shells contribute to a large amount of waste product in Southeast Asia due to the extensive culturing of the mollusks for consumption. As shown in various studies, like a penny, show cockle shell powder consists of 95 to 98 aragonite form of calcium carbonate. Calcium carbonate can change into hydroxyapatite. Hydroxyapatite is a source of calcium that is important compound to repair bonds. Hydroxyapatite is one of the calcium phosphate compounds. It is a well-known biomaterial where it is bioactivity and high biocompatibility and non-toxicity. Next, literature review. I have summarized the literature review and get 5 subtopics. It is important in this research. First, biomaterials application, COCKLE shell, calcium phosphate, hydroxyapatite, and the method of synthesis hydroxyapatite. For the first subtopic, it is biomaterial application. Ideal materials for cation metallic biomaterials as it possesses almost the closest similarity in chemical composition. Next, cockle shell. Blood cockle is a bivalve mollusk in the family Archidae and subfamily Undarin and locally known as kerang in Malaysia. Calcium phosphate. Calcium phosphate is a biomaterial which exhibits excellent biocompatibility, bioactivity, and biodegradability for bone replacement, and other medical applications. Hydroxyapatite, natural mineral form of calcium phosphate which consists of calcium phosphate and oxide in calcium phosphate group. For the last is a method synthesis hydroxyapatite. The homogeneous mixed powder will undergo sintering process as solid state reaction. Next, we want to see what the calcium phosphate can do for society today. So, for the first biomaterial application is homobody material income material. Next, fertilizer activities. Next, replacement in concrete material. Manufacturing of surgical devices, and lastly, catalyst for biodiesel production. So, we will go through then to the problem statement. For the first problem statement, the commercialization of cockle shell for produce hydroxyapatite not widely performed today. Next, incorporate byproduct and waste from cockle shell as alternative in obtaining hydroxyapatite. Then, cockle shell has no economic value available in large quantities and dumped in landfill. And the last problem statement, you can see the high consumption of hydroxyapatite is predicted to increase the target market over the forecast period. Objective for this research study. First, produce hydroxyapatite powders by ball milling method. Second, to characterize the physical and chemical properties of calcium phosphate. Third, to study the effect of solid state reactions between cockle shell powder and calcium pyrophosphate. Next, we go through to the scope of research. For the first one is to study the physical properties of cockle shells via heating process and dry in the oven for 1 hour at temperature of 110 degrees Celsius. Next, identify the best fit for ball milling process to get actual powder size. Then, investigate the reaction time that produce peroxyapatite from cockle shell. For the last part of research is observe the effect shape of the peroxyapatite particles in different synthetic reaction types in considering the crystallinity of peroxyapatite powders and improve synthesis method to produce active peroxyapatite from cockle shell. Methodology chapter. First, we start with the process flowchart explanation. I will start the process with the collecting the cockle shell, and then we go to the boiling and cleaning cockle shell, and then dry in oven, crushing the cockle shell, and let's go to the calcination process, and we have to go through the wet slurry precipitation technique. And then we go to the grinding using ball milling method, and we go to characterization analysis, and then analysis data and result, and then end of the process. Methodology research framework. The research framework has divided into 3 parts. For the first part is preparation of calcium phosphate from cockle shells. Second, synthesis of calcium hydroxyapatite, and the last is characterization of hydroxyapatite. First, I will explain for the preparation of calcium phosphate from cockle shell. Cockle shell were purchased from local market. Potassium dihydrogen phosphate used as a phosphate source. Next, the cockle shells were boiled and cleaned. The wet shells were dried in the oven, and the last step is a wet slurry precipitation. Next, we go to the second part, which is a synthesis of hydroxyapatite. The calcium oxide dissolved in water to obtain the calcium hydroxide. The potassium dihydrogen phosphate was dropped into calcium hydroxide solution. Mole ratio of calcium oxide to potassium dihydrogen phosphate was fixed at 1.67. Next, the reaction time will between about 3 hours to 5 hours. The mixture was then centrifuged at 300 rpm for 10 minutes only. For the last part for research framework is a characterization of hydroxyapatite. We have 4 software that we will do for the characterization of hydroxyapatite. For the first is the X-ray powder diffractometer (SRD). Second, Fourier transform infrared spectroscopy (FTIR). And then this is a scanning electron microscope (SEM). And the last part is a Raman spectroscopy. List of material and equipment. For the material part, we have to get a potassium dihydrogen phosphate. This material have to purchase and not available in FKP. While the deionized water will add the FKP, so we does not to purchase anymore. And the cockle shell we have to collect and purchase it. For the equipment, we have to go through the FKP lab only, like X-ray powder diffractometer (SRD), FTIR, SEM, Raman spectroscopy, and ball milling process, also in the FKP, pestle and mortality. For the next part is a chemical reaction. We can see it how the calcium carbonate, calcium oxide, that react others to produce the hydroxyapatite. Next, characterization of hydroxyapatite. I will explain for each of the process of the characterization of hydroxyapatite. First, SRD. The phases, crystalline size, and degree of crystallinity of the powders were analyzed using X-ray powder diffractometer. Next, Raman spectroscopy provide detailed information about chemical structure, phase, and polymorphic crystallinity and molecular interaction. Next, FTIR observe the molecular bond structure and presence of unknown materials in the sample. For the last process is SEM, which is we observe the morphology and microstructure of the sample. Expected result. So I will explain for the expected result for this research. This work aims to obtain this major significant result include SRD pattern of hydroxyapatite produced at different reaction times. Second, the hydroxyapatite produced at 3-hour reaction time will show broader peaks compared to 5-hour reaction time. Next, this indicates that hydroxyapatite with 5-hour reaction time has a higher crystallinity compared to hydroxyapatite with 3-hour reaction time. So this will conclude the hypothesis, which is increase the reaction time has increased the crystallinity of the hydroxyapatite. Next we go through for the problem that I have during in the semester, and next semester maybe, and the solution. For the first problem, maybe that I will face it, yes, which is a lack of experience handling the software. The new software is very make me hard to handle it. So I will ask for supervisor and assistant engineer for more information about the software. I will keep training it to gain knowledge, and will can control it future. Next, the second problem is a new terms for chemical substance. It's a very not unfamiliar with me today, but I will try my best to get new knowledge about the chemical substance. So I need to read more books and information about the chemical substances to get familiar with the new terms. So I will get very nice knowledge about the research. For the last problem is pandemic today, which is COVID-19 issues. It's got job, so we have to rental. So what we have a solution, just follow SOP from the university and government, and keep update for the new issue. For the last part, I will summarize my presentation. So my expectation for this research, I hope this research will succeed, inshallah, when the research meets the objective by raise awareness of possible ways to develop economic return for Malaysia. So thank you for listening to my presentation. I hope you're happy and satisfied with my work. And yang buruk datang daripada saya, yang baik datang daripada Allah Subhanahu Wa Taala. So thank you, stay safe. Assalamualaikum.